All right, thank you for everyone who's come and made it to the class. We'll begin from here. Today, we're looking at tutorial sheet 1. And as we look at tutorial sheet 1, this tutorial sheet 1 is based on the questions on sets. So I hope you went through the video and you understood the introduction which we had on sets. So we'll answer these questions which are based on those. Don't worry if you did not go through, we'll still cover the concepts that you must know as we are going to enter into it. So question 1 or part 1 of this says, which of the following are sets? So we have these listed here from 1 to 5, and they're asking us which of these are what assets. So how do we identify which of these are what assets? So to identify which of these assets, we must first define what a set is. So we say a set is a well-defined collection of what? Of distinct objects or elements. Set of what? A collection of objects called what? Elements. That's what a set is. So two things that we must note about this set. So two things we must note about the set is that number one, a set must be well-defined. So it must be well-defined. So what do we mean by well-defined? So by well-defined, it means that I must know exactly, or from whatever I read from the statement, I must be able to understand what is in that set. I must know what is in that set. There must be no ambiguity or subjectiveness to what is in the set. Another thing that we must note about sets is that the set must be what? Distinct. The set must be distinct. This means that each object in the collection must be unique. There are no duplicates that are allowed. We must what? Have unique elements in there. So if I have a set listing, let's say numbers 1, 2, 3, and I'm going, these are, let's say, they're natural numbers going all the way up to infinity. This means that this is how my set must be, and there must be no what elements that are repeating in here, which means if I have 1, I cannot write 1 comma 1 like this, like, yes, so I must just have the element 1 just like that and 2 just like that. They must be distinct. So these are the two points which we'll write on as we look at sets and as we are going to tackle these questions. So now let us answer these questions which we have here. Okay, so the first one says, the collection of all natural numbers. So which of the following are sets? So the collection of all natural numbers, is this a set? Of course, this one is going to be what to be a set. And the reason why we say it's a set is it is well defined. So it is well defined. We understand that the collection of natural numbers, there's no subjectiveness to what a natural number is. We all know that a natural number, these are what numbers that are used for counting, and they are what? They are positive, and they start from 1 all the way up to what? Up to infinity. So these are numbers going 1, 2, 3, all the way up to what? Up to infinity. We know the numbers. So they are going to be like this 1, 2, 3, all the way up to infinity. So there's no subjectiveness to this set of natural numbers. Thus, it's going to be what? To qualify to be a set. Okay, we move on to part 2. Part 2 is saying, so on the way as we are learning, if you have any question as we're answering these, please feel free to ask. Feel free to ask, and I'll answer as we are going. So part 2 says a collection of most dangerous animals in the world. So now, is this a set or is it not a set? So this one does not qualify to be a set because of the word dangerous itself. So here they're using the word dangerous, saying the collection of dangerous animals in the world. The word itself here, dangerous, is going to be what? To be subjective. Some animals that I myself might consider to be dangerous, other people might not consider it to be what? To be dangerous. So I can say maybe a lion is what? Is dangerous, but it's not everybody who thinks that a lion is what? Is dangerous. Maybe others feel the most dangerous animal is an eagle. So it's subjective to what? To them, and how you feel. There's no exact way we can measure this the how dangerous an animal is. Thus, this is not going to be what? To qualify to be a set because it won't be well defined. So part 2 is not a set. Then we have part 3. Part 3 says the collection of all female students in your group. The collection of all female students in your group. Okay, so at first glance, when you look at this, the collection of all female students in your group. So there's no, it's not sure which group they actually were talking about. So if you are talking of maybe group of friends, you have even different type of friends. Let's say friends that you have at home, friends you have in school, friends you have. So it cannot be that clear which females you are talking about. But in this case, where we're looking at a mathematical point of view, when they say a collection of all female students in your group, the group itself that they'll be talking about will be well defined. So this can be what? Maybe a TG group, this can be a lecture group, and of course, we can be able to identify which ones are female. We can be able to count, okay, these are females, and okay, these are what? These are males. But now the collection of what? Of female students is easily identified in what? In a group. In a classroom, you're able to tell which ones are females and which ones are what and are not females. There's no two ways about it. So this will qualify to be a set. Then we have part 4. Part 4 says the collection of all hospitals in Zambia. Okay, so this is also well defined because I know what a hospital is, and I can count the hospitals and I identify the hospitals. I know there's Levy, I know there's UTH, there's Mainasoko. So it's going to be what? A well-defined collection. So this also will qualify to be what? To be a set. Then we have part 5. Part 5 says the collection of what? 5 most talented singers in Zambia. Collection of 5 most talented singers in what? In Zambia. So when we look at this, talented, most talented, the word here they are using, most talented. This is subjective. Yeah, because I might feel, for example, I might feel your maps is what is most talented, but this is not the feeling of everyone. So how am I going to know if he's going to be in that set or what, or not to be in that set? Others might feel no, yeah, Chile one is what is most talented. So how am I going to draw up what this list? So this list is not going to have what is not going to have uh distinct objects, and of course it's not that well defined because we don't know uh, the criteria of choosing most talented. So meaning we all have different sets that we come up with. So this itself in itself, because it's not what well defined, this will not qualify to be a set. So this is not a set. This is not a set. Part 5 is not a set. Okay. So this is all about all these, identifying which one is a set and which one is not a set. I don't know if I have any question here before we move on to the next question. Okay, if it's clear, let's say it's clear. Anyone to give confirmation?
Clear.
All right, thank you. So we move on to the next one. So part 2 says, let A, so we have the set A, which is being given by this. So set A has elements. You can see there's the element 1, and the other element that is in here is the set containing the elements A and B. So notice that I've used that the other element is the set containing what? A and B. And note that A and B is a member of what? Of the set A. Okay. So which of the following statements are what? Are true, and which ones are what? Are false. So I have that number what? Number 1 says 1 is a member of what? Of A. So is this true or false? So I can see from the elements listed in A, elements listed in A, there's just the element itself 1 and the set containing 1
Let me put here.
and 1 and okay, 1 and
What is
I
it?
mean A and what? A and B. A and B. Okay. Kindly mute your mics, please. All right. So the other one, as we said, is the set containing what? A and what? And B. That's the other element that is in here. So is 1 a member of this set A? Yes, 1 is a member of this set A, meaning this statement is going to be what? To be true. Then we have part 2. So part 2 says a member of what? Uh, the element being a member of the set A. So as we can see that I have the elements that are in what? That are in this set A is 1 and the set containing A and B. So A is not in the set what? Is not listed as an element in the set A, but it is what? It is in this set here that is what? Which is the set in the set A. So this A is not listed as an element in what? In the set A. Thus, A is not a member of what? Of the set A. So this statement here is what? Is false. False is gonna be false. Okay, then I have part 3. Part 3 says I have the set A or the element or the set A. So the set A, comma B being a subset of what? Of A. So what is the definition of what? Of a subset? This is just a set containing what? Another set. So a set contained in a what? In another set. So as I can see here, okay, part saying repeat the explanation for part 3. Part 3. Okay, we are doing part 3 right now, so I don't know if you mean part 2. The one who's asked the question, do you mean part 2 or do you mean? Okay, part 2. All right. So what I'm saying or what we are saying is this here, the set A, as we can see, set A, the listed elements in set A. So we list elements. Remember in roster form, we said we list elements by what? By listing, right? So if I have a set BI, my elements, let's say I have 1, 3, and what? And 4. So I have listed these and they are separated by what? By a comma. So I can see that in this set A, the elements they've listed here, there's 1, and they've listed what? A set here. This set here is an what? An element of this set A. So now we are saying they are saying A being a member of what? Of the set A. So as we can see here, is this element A listed in what? In the set in this set A. So we see that it is not listed in the set A, but it is contained in the what? In the set containing A and B. So let me go back to this B part here. So if I say there's A here. So I can see that A here is listed as a what? As a member of this set B. So meaning A is going to qualify to be a member of set B. But in this case, on top here where we're dealing with A, where we're dealing with A here, we see that they have not listed A as a what? As an element, but they've listed this entire set as an element, and the set and the element A is contained in this set which contains A and what? A and B. So when we say here saying is a member of B, when we say A is a member of B, then it means that A has been what? This A has been listed in the set A. So that's when this would have what? Would have qualified. But now, because it's not listed, so that will not qualify and that will be false. Okay. All right. Thank you. So we can move on now to part 3. And then, so part 3 says, okay. So part 3 says, uh, A comma B being what? A subset of A, like this. So we're saying a subset is just a set being that is contained in what? In another set. So if I have the set, let's say I have the set, I have the set X. The set X has the elements 1, 2, 3, 4, 5, and I have the set Y, and Y has the elements 2 and what? And 4. So we see that this set Y is a what? Is a subset of X, because this set here, I can what? I can find it in this set X, or these elements that are listed in this set Y are contained in what? In the set X. So even when drawing as a Venn diagram, you would see that if I draw, I can draw to say I have my set X here and I have my set Y there, and I can have 2 and 4 there, and I can have the rest that sit there like that. So I see that the set X itself contains all these elements 1, 2, 3, 4, and 5, but the set Y only contains 2 and what and 4. So the set Y is just a subset of the set X. So now when we look at this set here, is it a subset of the set A? Of course, we can see it here, and it is contained in what? In a set A. So this is going to be a subset, and this is going to be what to be true. So if you look at it, so informally, as we did with the what with the sets, as we did with the previous sets, where we say we have this set here, and we have like that. So this set there is just the set there containing A and what? A and B. Then we're saying it's containing A and B. Then we're saying uh this other element is just what? One there. So informally, just for you to have a pictorial diagram, not say that this is how it's done, but yeah, just have a picture of what is going on, is that this here is contained in what? In the set what? In the set A, and thus it's going to be a subset of that set there. So meaning that this here will qualify to be a subset. This entire set here is going to qualify to be a subset of the set A. So this here is going to be true. Okay, let's move on to the next part. So the next part has 1, A, and B like this, saying this to be a subset of what? Of A. So we can check this. Is this set here a subset of what? Or subset of A? So when we look at this, so wow, we see that this one is contained in what? One is contained in what? In A. But the elements, as we said, the elements A and B are not contained in what? Are not contained in A. But what is contained in A is the set containing A and B, not the elements A and B. So because the elements themselves A and B are not contained in what? In the set A, so it means that we cannot list this as 1, A, A, 1, A, B. Thus, this here cannot be what? True. This here cannot be contained in what? In A. Thus, this is going to be what? To be false. So this here, we conclude that this will be what? Will be false. Okay. Then we move on to the last one. The last one is true. When we look at that, we have the set 1, the set containing what? 1. And when we see here, we have the element what? 1 there contained in what? In A. So 1 is a subset of what? Of the set A. All right. Don't know if I have any questions here before we move on to part 3 of the tutorial sheet. Okay, so we have now the next questions that are given here. And the next questions are saying express the following sets in roster form. Express the following sets in roster form. So roster form is just or known as also known as tabular form, is just a form of set representation where we list out our our elements. So we have part so we have part A there, which is having this is a set A. So we can read this. This is a set A, set of OX such that X is what? Is a letter of the word Mississippi. So X, we are saying, is a member of this letter what? Mississippi. So now, if X is a letter of that word Mississippi, and Mississippi contains what letters? Mississippi contains the letter M, the letter I, the letter S, and the letter what? P. So it contains how many letters? I can see M there. I can see the letter what? I, and I can see the letter S and the letter what? P. Of course, these like S and I and P are what? Are repeating. They are not written once. So now they are say as we said that a set must be what? Well defined and must be what? Distinct. So we cannot repeat these what? These letters that are there like S and what? S and P and all those, we cannot what? Repeat them. So when we are talking of the set here, how we're going to list it, the set A is going to be, so we are listing because it's roster form. because they've told us X is a member of what? This set, containing the letters what? Mississippi. So the word, the letters themselves we have is M, I, S, and what? P. So this here is going to be my set A. This is my set A. Okay. So now let's look at part B of the question. Part B of the question, B of the question says X such that X is a prime factor of what? 30. X such that X is a prime factor of 30. So now I must identify here what they are using. They've used the term what? Prime, number one. So a prime number is a number which is what? Divisible by 1 and itself. And that prime, we're saying it must be what? A factor. That prime must be a factor of what? Of 30. Meaning that prime number must divide into what? Into 30. So it dividing into 30, what numbers here divide into what? Into 30. So the prime factors of these numbers, we are saying that they are numbers that when we divide, so we look at the primes that we're going to be what? Dividing into 30, or that divide into what? Into 30. And those primes, we have what? We have 2. 2 divides into there 15 times. Then we have what? We have 3. So 3 divides also here into us is into 30 10 times. And also we have what other number do we have? So we have the other prime here we're going to have is what? Is 5. 5 divides into there. Uh, 5 divides into 30. That's how many times? 3 times. So not 3 times. That divides into there 6 times. I mean, so 6 times. Yeah. So these here are the prime factors that I'm going to want to get. So these here will be the ones that will be contained in the set B. So B is just going to be a set such that I have 2, 3, and 5. These here are my prime factors. Okay, I move on to part C. Part C says the set of OX. Okay, what of 6? Okay, somebody's asking what of 6. So 6, we by definition of a prime number, is a number which is only divisible by 1 and itself. But 6, I can divide 6. Yes, 6 is divisible by 1, and 6 is divisible by itself. But also 6 is divisible by what? By 2, and it is divisible by what? By 3. So meaning that this 6 is going to disqualify to be a prime number. So it cannot be a prime factor of 30. All right, I hope that is clear. Okay, somebody asked, and why ending at 5? Why did we end listing at what? At 5. So we can check. Okay, let's list down the factors first of all of what? Of 30. What are the factors of 30? So the factors of 30 that we have, of course, 1 divides into there. We have 2, we have 3, we have 5, we have 6, we have 15, and we have what? 30. So now when we look at these here that we've listed, you identify which ones now are prime. So we know that prime numbers start from 2 going up to this way, and they are divisible. They start from 2 going to infinity, and they are numbers that are divisible by 1 and itself. So as I can see here, 2 is divisible by what? By 1 and itself. 3 is only divisible by 1 and itself. 5 divisible by 1 and itself. When I look at this here, it has other what? It can be divided by 3 and 2, as we said. 15 also can be divided by what? By other numbers like 5 and what? And 3 can divide into 15. Here, 10, 2, 6, 5, 15, all those can divide into what? So it will disqualify to be what? To be a prime number. So meaning the only prime numbers I'm going to have there, so the prime factors of 30, as listed there, are just going to be 2, 3, and 5. I don't know if that was clear. Uh, okay. I don't know if that was clear. Somebody's saying also 10. Also 10. So when we look at 10, 10 is divisible by what? We can divide 2 into 10, can divide 5 into 10. So it disqualifies. The number must only be divisible by 1 and the number itself. So when you look at 2, I can only divide 2 by 1 and what? And 2. 3, number that does not leave a remainder. Like then the number that I must divide into these here must not leave what? Must not leave a remainder. So I must divide. So when I divide 3 into 3, it gives me 1. When I divide 1 into 3, it gives me what? 3. So there are no remainders there. I don't know if that is clear. Okay, you mentioned the list of factors. All right, we missed out 10 here. All right, thank you very much. Okay, so 10 is indeed a factor of 30. Yeah, all right. Any question on how we obtained these numbers here in the set C? That's 2, 3, and 5. Any question there? Okay, somebody is asking what of 7, uh, 11, 13, and 17. Okay, so here remember the question is saying prime and factors. What are factors? So factors are numbers that are going to divide into 30 without giving us what? A remainder. When you look at all these here, these numbers here that we listed, including 10 here, these we can divide into what? Into 30, and they do not give us a remainder. So these qualify to be factors of 30. The other numbers that you've listed in the question in the chat box, uh, 17, 11, and what, those cannot divide into what? Into 30 without leaving a remainder. Okay, is that clear now for everyone? We move on to the next part. Okay, thank you. So let's look at part D. So part D, oh, part C, we have to look at part C. That was part B, sorry, I was writing C. So that was part B. So that was B, and we had 2, 5, and what? We had 2, 3, and 5. Okay. I think I had a mix up because I'd moved on to C myself. All right, so let's look at C now. C is given as the set of all x such that x is a root of what? Of, so they've given us this equation that is there. So to list out those elements, we just have to solve that equation. So 4x and equal to what? To 0. Here we can factor out an x. I'll factor out x here and have x squared minus 4 there equal to 0. Then here inside, by difference of two squares, I'll just have x outside. Then that will be x minus 2, and I'll have x plus 2. And this is going to give me 0. Then I can equate each of these parts, each of these linear factors to what? To 0. So I'll have x equal to 0, and I'll have x minus 2 equal to 0, and I'll have x plus 2 equal to 0. So this means that the values of x that I'm going to get is going to be x equal to 0, and I have x equal to what? To 2, and I'll have x equal to negative 2. So these here are the elements that are contained in what? In the set. Then I can list these elements. So meaning the set C is just going to be equal to, so it has the elements negative 2, it has 0, and it has what? 2, like this. Okay, hope that is clear. Move on to the next one. So the next one, that is part D. So part D, okay, so part D, they're telling us that x is a member of, so n meaning natural numbers, and they are saying x squared is less than what? 9, and x cubed is less than 130. So how do we find out this? So when we look at x squared greater than what? Than 9, if I introduce the square root on both sides, here and there, so because I'm squaring here, I'm not going to get positive, negative and positive. I'll just get the positive version of this, and that is going to be what? Give me 3. So I'll have 3 on that other one. Then on the other one, I have x cubed less than what? 130. So I know that 130 is not, 130 is not I can say what? A perfect cube. So if I introduce the cube this side, if I introduce this side, X is just going to be, so I introduce a cube, this, and on the other side, this here is going to be, I know that cube like this, 125, this gives me 5. So if it's 130, this is going to be close to 5. At least it's going to be maybe 5.1 like this, approximately, if we say it's going to be something like this. Okay, so you can check even the exact one on what on the calculator, but it's not really yeah, really going to affect whatever we do. So let's say we have this here. So this means that our values of x, one, the values of x have to be greater than 3, but yet the values of x also have to be less than what? 5.1. So, okay. Okay, so somebody's asking if I repeat on C. All right, let me finish up on D, then we'll repeat on C. So when you look at this, we have x being greater than 3 and x being less than 5.1. So if it's less than that, what we're going to do now, they're telling us that x is a member of natural numbers. So natural numbers, we know they start from 1, two, they are counting numbers. 1, 2, 3, 4, 5, up to what? Up to infinity. Those they are going to be the natural numbers. So now, if I have those natural numbers, I have to check which natural numbers are what? Are greater than what? 3, but yet the natural numbers again, they have to be less than 5.1. Have to be less than 5.1. So, being greater than 3, meaning 3 is not part of this, what natural number follows after 3? It is 4. Then here it's saying less than 5.1. So less than 5.1, what number is less than what? 5.1 here? It's gonna be 5. And of course, I know going down here, I'll still have 4, and I'll have what? Just like that, I'll have 4, 5, and I'll have 4. Here, greater than 3, it's gonna be what? 5. And because they're telling us the numbers have to be in between here, greater than 3, but less than 5.1. And these are the natural numbers that are what? Greater than 3 and less than 5.9, meaning the set D is just going to be the set containing 4 and 5. So this here is going to be the set D. Okay. Now, allow me to repeat part C. Somebody said they did not clearly understand part C. So with part C, you have x cubed minus 4x equal to what? To 0. So with this one here, you have to solve for the values of x. So first of all, we factored out what? An x here. So when I factor out x here, I'll get x squared there, and there I'll just get 4, because the x divides into this here, and I'll just remain with 4. By difference of two squares, I can write that as x squared, then minus 2 squared, because when I raise 2 to the power 2, it's just going to give me 4, and this is going to be equal to 0. And when I write this, I can later on, I can factorize this further to x minus 2, and then x plus 2, and this is going to be equal to 0. Okay, somebody wants to ask a question? I don't know, they've unmuted their mics. Okay, so when we have that, meaning I have x here being equal to 0, this other linear factor equal to 0, and also this other factor equal to what? To 0. Meaning x is going to be equal to 0. I have x minus 2 equal to 0, meaning x is going to be equal to 2. And I have x plus 2 equal to 0, meaning x is going to be equal to negative 2. So this here is going to be what? This here is going to be, these here are the values of x. So I have 0, negative 2, and 2. These are the values of x. And those being the values of x, meaning those are what are going to sit in the set what? In the set C. Meaning the set C is just going to be equal to negative 2, 0, and 2. So this is the set C. Okay, I don't know if that's clear now. Okay. Okay, I hope that is clear. So I'll move on to part E. So part E. So part E, uh, part E, I have that. Uh, so part E has X, set of all X such that X, okay, uh, Okay, somebody is asking what happened to 4 on here. Okay, so on part C, what happened to 4? Remember, we are cubed and 4x here equal to 0. There's, then when you factor out x, as we said, you have x squared minus 4 here remaining, and this will be equal to 0. I know I can write this 4 as 2 to the power 2, because 2 to the power 2 is 2 times 2, and this is just equal to 4. So that was what was going on with f4. And when you have that x2, you have this here. You can factor out this here. I'm saying this is the difference of what? Of two squares, because you have this square and that square. And by difference of two square, I know you guys have this basic knowledge. It's going to be x plus this, and the other one x minus 2. So that is what is happening there. Okay. Uh, okay, so you can pre-watch the video if you don't. I understand it's going to be uploaded. But then let me just clear up this part E, because we have to do the last part of the question, and we call it a day. So the set of OX such that x, so x is defined. X is defined by this equation where you have n to the power 4 minus 1, and they're telling you that n is a member of the natural numbers. And at the same time, as n is a member of natural numbers, this n is less than what? Than 4. So meaning I can list those values of n. Since it's a natural number, n is less than 4. So the natural numbers will start 1, 2, 3. It's less than 4, meaning 4 is not part of it. So meaning these here are the values of n. So they are, those being the values of n, what am I gonna do now with them? So uh, I'm going to what? To replace now for these values of what? For these values of n. So if n is 1, let's start if n is what? N is equal to 1. So if n is 1, I'll have x is going to be equal to, so 1 to the power 4 minus 1. 1 squared is just going to be what? To be 1. And I have 1 minus 1, and this is going to give me that x is just going to be equal to 0. So the first value I have is 0. Then if n is equal to what? To 2. Let me replace. So x to the power what? So I have 4 there to the 2, I mean 2 to the power 4 and minus 1. So what am I going to get when I replace that? So what is 2 to the power 4? 2 to the power 4 is just 16, and I have minus 1. 16 minus 1, this gives me 15. So 15 is my second value. Then the last one, for x, when n is what? When n is, so we're saying if n is equal to, so if n is equal to 3, so I'll have that x is going to be equal to n. We've said n is what? Is 3. So n is 3, meaning I'll have 3. I'll have 3 raised to the power 4 minus 1. And 3 raised to the power 4 is just going to give me 81. So that is going to be, this is going to be equal to 81 minus 1. And this is going to just be 80. So meaning the values that I have, when n is 1, I have 0. When n is 2, I have 15. And when n is 3, I have what? 8. So meaning the set E is just going to be equal to 0, 15, and 8. So this is the set E. Okay, here, I don't know. Do we have any questions? Is anybody lost or behind? Okay, so now let's do the next. Okay, okay. You can ask your question, please. You can unmute your mic, then ask where you are not clear. Okay, the person who's texted, that's yeah, you can ask. Okay, if you're unable to use your mic, just kindly type. So are we replacing n with natural numbers? Yes, yes, we are replacing n with natural numbers, because they are telling us that here when we look at where n is, they're saying n is a member of the natural numbers. So meaning our n can only be replaced with what? With natural numbers. That's starting. And these natural numbers again have to be less than 4. That's the other condition that's given there. So meaning that our natural numbers that we have, of course, less than 4, that is just 1, 2, and 3. Okay. All right. There's somebody who has raised their hand. You can, yeah, you can ask your question. Okay. You can ask your question. The one who's raised their hand, yeah, you're able to. Okay. So question D. Yeah, so is it clear on this how we are getting the values of n? Because it's given, the condition is given here. N has to be a member of the natural numbers, and n has to be less than what? Less than 4. So this is what we are getting. So if we're getting those values, natural numbers, as we know, they're just counting numbers 1, 2, 3, 4, up to all the way to infinity. But they've given us a limit here because they've said n is less than what? Than 4. And I can list those numbers. That's just n to be equal to 1, 2, and 3. So these here are going to be the n's that I'll consider for finding the values of what? Of x. Yeah, okay. So all right. So let's do D again. People are saying they are not clear with D. So with D, okay, with D, as we said, it's a set of OX. So X is going to be a natural number. As we'll be getting, X must be a natural number. And we know natural numbers will start from 1, 2, 3, all the way up to what? Infinity. Those are gonna be natural numbers. So we're clear on that one. X must be what? A natural number. That's the first condition that is given here. And they've given us that x squared is less than what? 9. But us, our interest is not on x squared. Our interest is on what? Is on finding x. So if I introduce a square root here and I introduce the other square root there, I'll have that x is going to be greater than 3. So they've said x is a natural number. That's the reason why I cannot get the plus. So you know that when you introduce a square root like this, when you introduce a square root, we introduce a plus minus here, such that we have our values to be plus minus. We have 3 and -3. But because they are telling us that x is a what? Is a natural number, meaning we cannot have -3, because -3 is not a natural number. Because we know that natural numbers will start from 1 going up to infinity. That's the reason why we're getting x greater than what? Than 3, and not x, not including the part of the -3. Same even with the one with the where we have a cube here. So there are two conditions that are given: x squared greater than 9 and x cubed less than 130. But we're interested in what? In x. So the first part we've done here. The other one, when we introduce a cube root, here I introduce a cube root. Then on the other side, I also introduce my what? My cube root, 130 there. So the cube root that is closer to here, the perfect cube root that I have is what? Is that of 125. When I cube 125, I get 5. And I see that 125 here is closer to what? To 130. So meaning even the cube root here, when I get here, the cube of that is going to be closer. So I'll have that it's going to be closer. Maybe it's going to be 1.5.1. And I try to apply this by three times. It's going to give me somewhere close to what? To 130. So I know those are the two conditions now that I'm having. So let me write them now down, because those are the two conditions now that I'm having on that part. So I have that x is greater than 3 and x is less than 5.1. But they are saying that x, the first condition is x is a natural number. X is a natural number. When you look at this 5.1, this is not a natural number, because uh, natural numbers are what? Are integers, like distinct. They do not have points. They're just going to be 1, 2, 3, 4. Those are going to be the natural numbers. And they start from 1 going to 1 to infinity. This set here, where I have 1 all the way up to infinity, this is going to be the set of natural numbers. So now in between these, what natural numbers do I have? So they're telling me in between 3 and 5, what are the natural numbers that I have? So I have 4 and I have what? 5, because they're saying it's greater than 3. So numbers greater than 3, what? 4. But It has to be less than what? 5.1. So that is 4 and what? And 5. So that is going to be the set that is going to be D going to be equal to 4 and 5. So this here is going to be my set D. I don't know if that is clear now. Okay, is that clear on this one? Okay, for us to make progress, the one who just asked the last question, sorry, we won't tackle it, but then you can just go through it again as I say in the recorded part, because I think I've explained it twice already. So for the sake of progress, let's just move on to the last part. Yeah. If you have any other questions, you can still send them to my inbox. I'll answer them. Okay, can't see the last question. Where is the last question? Okay, it's here. So the last question now, they are asking us to do the opposites now, where we write them in set bidder notation. So set bidder notation, those the ones we had before, they were in what? They were in set bidder notation and we're writing them in roster form. These here have been given in roster form and we have to write them in set bidder notation. So I have the first one. I have the set A. So what can I observe about the set A? So when I look at the set A, all these that are here, 1, 2, 3, 4, 5, 18. All these here can divide into what? Into the number what? 36. They are factors, or they can divide into the number what? 36. So I can write this. So for the set bidder notation, it's not gonna be unique because you can describe it in different ways. So I can write this as the set of OX such that X is X is a positive what? Integer, or is a positive, yeah, is a positive integer divisor of what? Of 36. Positive, uh, okay, let me get that. X is a positive integer divisor of 36. Yeah, integer divisor of what? Of 36. You can write it like that. Or if you saw the one which we had before, the one on the previous one, you see here why they wrote x is a prime factor of what? Or you can write that x is just a factor. So x, okay, not that. So you can write that as a equal to x such that x is a positive. So positive, I'm just writing a plus and VE, positive factor of 36. And I can see that I can define it like this or this way. It's gonna be the same. Okay. So this is for part one. That's how you write it in Sepida notation. Then let's go on to part two. So uh, part two says, so we have this, you have plus minus 4, plus minus 5, plus minus what, 6. Those are what you're having there. So how do you describe that? So you can write that as the set B, so you have a set, so it's X, set of all X such that, so as you can see here, X is what? Is an integer. It's a positive and negative integer. So you can write it in general to just say X is a what? Is an integer. So you can say X, a member of the integers like this. Yeah, member of the integers. Okay, so and by definition, so definition of how a modulus is, you guys will later understand this, but a modulus is something like this, where I have x here. The values of x here are always going to give me what? Positive values. But redefining this, you're going to get something plus minus. So if you have a number here like this in this is just gonna be redefined as plus minus. In this case, that's what we'll use. You guys will later understand it better as we look at modulus functions and all. Yeah, but for now, just write it like this. And we're saying, so it's a member of the integers. Both are saying positive and negative. And we're saying that x modulus like this is going to be a member of Uh, that's it. 4, 5, and what? And 6. So this is how we would describe our set X. So this is how it's gonna be. Okay, on this one, yeah, as I said, you can better off understand it when you just research on what a modulus is, and you better off understand it. Okay, let's do this one. This part C here. Or if you want, you would have written that to say B such that X is a member of. So X is gonna be a member of how can I define this? So X being a member of uh okay, so let's say where we say we okay, let me write this first. So X such that X is contained, or X is the member in the set that has the roots of that is 16, root over 25, and uh root of yeah root of that's 36, and X is what is an integer. X is an integer, meaning it can be positive or negative. So this here, because when you define this here, you get 4, there you get 5, there you get 6, and plus minus, because we're talking that these are integers. So you could have written it like this as well. So yeah, as I said, set video notation is not really unique. You can write it, anyone can write it in a different way, as long as it defines what you have in that set. Okay, so let's move on to this other one. So part C is defined or described by an equation where we're saying we have n to the power 3 plus 1, n to the power 3 plus 1, where n to the power 3 plus 1, where we have the values of 1, or the values of n, to be equal to 1, 2, 3, 4, and what? And 5. So these are the values of what? Of n. As I said, it's not unique. So when I put 1 here, I'll have 1 plus 1. 1 cubed is just going to be 1, and I have 1 plus 1, and this will give me 2. And 2 there is the first element. You put 2 there, you have 2 cubed plus 1. 2 cubed is just going to give you what? This is going to give you 8. And you have 8 plus 1. This is going to give you 9. So 9 is going to be the next number there. And you can do this up to what? Up to 5. And this is going to give you what? The last number there, which is 125. So you can write this now. Let's say to say xc such that x, then you say x is equal to, like the previous, as you see, you define x by the equation n to the power 3 plus 1. Then we're saying n is a what? Is a natural number. As you can see, it's a member of what? The natural numbers. And not only it being a natural number, we see that n, and we're saying n is defined is less than what? Than 5. Sorry, not less than 5, but we're saying less than 6. It's less than 6. So if you say less than, meaning it's gonna start from 5, going up to what? Up to 1. 5. So to be 1, 2, 3, up to 5. Or if you wanted to write, then here you can close. If you wanted to write 5 there, you would have put an equal to sign. So that would be C. You can write it as well as C, such that x is equal to n to the power 3 plus 1. N is a natural number, and n is less than or equal to 5. So this here is going to be another way you can define this. Okay, let's look at part D. And part D is just D equal to, so for D, it's really hard to see at first, like what is going on, but you can define it. And part D is going to be defined as, so you have, okay, you observe that it's a set of x such that you have x being defined by, so being defined by n over what? Over d, because it's a fraction. We have a number on top in the numerator and down d representing the what? The denominator. So where the values of what? The values of n n is taking up which values? So on top here, as you can see, the values that n is taking up, there's only 1, 2, 3, and what? And 1. So n can just take up values 1 and what? 1 and 3. That's there, which is on top. And down there, you can write also, and we see that D is a member of the set, and what numbers are what? Are being taken down in the denominator. There's 5, 3, 7, and what? And 2. So meaning that is going to be your set there. You write 2, 3, 5, and what? And 7. This here is going to be your set. And of course, D and N both are what? These are members of what? Of integers. These are integers, so you can indicate that as well. So this is what is going to be gonna define your what? Your set D. Okay, let's do the concluding question and we wrap up with everything. Yeah, because we have to close this class. So E, as we can see, the set E, what is happening here is that in the denominator, as you can see, it's just given by this equation where we have n what squared. When you put 1 there, 1 squared is just going to be 1 over 1, and this is going to give you 1. You put 2 there, 2 squared is just 1 over what? This is 1 over 4. 2 times 2 is 4. You put 3 there, 3 squared. 3 squared is just what? 1 over 9. And this is going up to what? Up to infinity. So we see that the set E is just going to be the set of OX. Set of OX such that X is going to be, so X is defined or given by the equation n over what? N squared. And we are saying that so we're saying where what? N is what? Is a positive natural number. So you can indicate it by, okay, let me just erase this here. Okay, so it's a positive integer, I mean, it's a positive integer, or it's a positive what? Natural number, or you can say it's a natural number. Yeah, you can indicate this. That's why I'm saying this is unique. You can indicate this, we will know. Or you can also indicate, you can write, instead of writing that there, you can write what? You can just write that this is a member of the natural numbers, like this. So this is what is defining. Yeah, you can write it like this. So this is what is defining the set E. Okay, so this is the end of this class. I don't know if there are any questions to conclude as we are going to close. Okay, I do not have any questions, so thank you very much, everybody. Okay, there's a question. Understood. Thank you, sir. Okay. So, you're welcome, everybody. Thank you for attending today's class. Remember, guys, to subscribe to the YouTube channel if you've not hit that subscribe button. And tell others, inform others, and share the link with others that they also get the same knowledge you guys are getting.